Hello all, this is Pranav from DFI India and I welcome you all to Continuous Flight Auger CFA Piles Theory, Prospects and Application in India workshop. Few of the instructions: recording of this program is prohibited and online recording of this program will be emailed to you in approximately 2 weeks. Few of your control panel details. If you want to see your clear screen, you can hide your control panel by clicking on the red arrow. And if the GoToWebinar window is not in maximized mode, you can click on the third button and you can view it in full screen mode. Anytime during the presentation, you can ask your question to the presenter. Use the questions tab, put in your question. Don't forget to put your name and your organization name. And we have put few flyers and brochures for you to download. Anytime during the program, you can download these brochures and refer. Now I welcome our session moderator for today, Dr. B. Manna. He is Associate Professor from IIT Delhi. He is also co-chair of IGS Delhi chapter. Dr. Manna completed his BE in Civil Engineering from IIEST Sibpur in 2001 and his Masters from IIT Kanpur in 2005. He earned his PhD from IIT Kharagpur in 2009. Dr. Manna joined IIT Delhi as Assistant Professor in 2010. His research interests are pile foundation, slope stability analysis, earth retaining structures, foundations for industrial machines, ground improvement, soil dynamics, railway geotechnology, and vibration isolation. Dr. Manna has published 23 journal papers, 68 conference papers, and edited 2 books. He is member of various professional organizations like ASCE, DFI, IGS, ISSMG, to name a few. And he is currently serving as co-chair of IGS Delhi chapter. So Dr. Manna, I welcome you to take over the session and kindly carry forward.
Thank you so much for introducing me. Hello everyone. Thank you so much. So I'll just briefly, introduce about the sequence of the workshop. So today, first Ms. Aarti Bhargava will give you the workshop overview, and about the IGS Delhi chapter activities. And Mr. G. Venkataprasad will give the overview of the DFI of India activities. And there we have three presentations on pile foundations. So first by Professor J.T. Shahu from IIT Delhi. We will talk on pile foundation, difficulties in alluvial soil, and the possible way forward. So typically, the duration of the presentation will be 30 minutes, and then we'll have a 10 minutes question answer round. So you can put up the question mentioning your name and the organization. So in that, I'll just forward the question to the speaker, and we'll have some discussion over there. So then we have the second presentation by Mr. Andres on world-class studies on CFA piles from a typical project to an extreme application. Then again we have some question answer round. And the last presentation by Dr. Sunil. He will talk on CFA piles, design approaches, suitability, and application in India. And then we have some concluding remarks. So now first, I just introduce Ms. Aarti Bhargava. It's my pleasure. So Ms. Aarti has a 30+ years experience, has a successful and progressive experience in leading instrumentation company, EMIN Limited. She's currently playing a dual role at EMIN as a senior general manager, heading marketing and communications group, and also as national head sales of civil engineering range of equipment. She is an active member of Indian Geotechnical Society, main body, for last more than 20 years, and she has been playing an active role in IGS Delhi chapter over more than last 10 years. She has been member of executive committee of the 3 consecutive terms and is currently the chairperson of IGS Delhi chapter. Under her chairmanship, IGS Delhi chapter received the Best Chapter Award in the year 2020. And she is also member of ISRM, Indian Road Congress, and ISRMTD. So I welcome Ms. Arti Bhargava and I request you to give the overview about the workshop and the IGS Delhi chapter. So over to Ms. Arti Bhargava. Thank you.
Thank you so much, Dr. Manna and Pranav. A very good evening to all the participants here. Evenings are the way of life to say you're closer to your dreams. No matter how bad the day has been, but the beauty of the setting sun makes everything serene. And when we look at the sun, we just say we still have hope. I know pandemic has brought a lot of challenges for all of us, but we still have the hope to live, hope to connect to each other, and also hope to learn from each other. So I welcome you all once again on behalf of IGS Delhi chapter and DFI India to this webinar. We've had huge response on this webinar, and I'm sure it will go great. And so we are glad that you are here. Coming together is a beginning. Keeping together is progress. Working together is success. That is the very reason why IGS Delhi chapter and DFI has come close to organize this webinar. And I hope to see many more webinars in the future as well. Not only webinars, but a lot of events, when we start meeting in person, actually. When we talk of this workshop is a part of dissemination efforts by both the associations, which will help you gain a deeper understanding on CFA piling technology from the concept to implementation. So we do have our esteemed speakers here, Dr. J.P. Shahu, Mr. Andres from Keller UK, and Dr. Sunil S. Basarkar. There is definitely a good news on the card. A good news which means a greater scope for civil engineering and construction industry. Government of India has, as you already would know, has plans to invest around 10 million crores in the infrastructure projects in the next 5 years. That would mean more and more work for the civil engineers and construction industry. The global experience suggests that the construction projects do not complete foundations at the scheduled time, which end up in cost escalations and also time delays. CFA, continuous flight auger pile technology, is one of such foundation systems that has great potential to improve the speed of foundation construction in India. So let's see what is this concept all about and how do we implement in India. So let's be the game changer. This is a technology which is truly a game changer in the Indian piling industry, and let's see how it can be implemented in India. So this is an effort to make you the game changer. Before we move on, I'll give you a brief on IGS Delhi chapter, which is partnering DFI on this event. Indian Geotechnical Society is a registered society which aims at promoting cooperation amongst engineers, professionals, and scientists for advancement of knowledge in the field of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, a lot of elite areas, and also practical applications. IGS Delhi chapter provides a similar platform for the geotechnical engineers in Delhi and basically the NCR region. It's a non-profit association run by the professionals working in different verticals. It was established in 1982. It is part of the main IGS body, and it has 49 chapters across India. This is the largest chapter of IGS and known to be one of the most vibrant chapters across the country. If you are taking up a membership of IGS, the advantages are to get associated with the eminent professionals, It gives you an opportunity to network with the professionals, meet your colleagues, exchange your ideas, establish career connections, and also update on the recent developments. You can also enjoy discounts on various activities and also avail an opportunity to advertise your products, whenever we are organizing the exhibition. You also get an access to the periodic newsletter of the IGS Delhi chapter. Now, just a glimpse on some of the activities organized by IGS Delhi chapter, which will give you a panoramic view of what all we have been doing at IGS Delhi chapter. We arranged for a technical lecture on GPR technologies. This was arranged, and there was a lecture arranged by Mr. Robert Perello from GSSI USA, who also gave the technical lecture, and there was a demonstration of the latest equipment there in coordination with the GPR technology. We had another lecture on self-balancing technology of pile foundation. Here we had the experts from School of Engineering, Southeast University, China. There was another lecture held at CRRI with IGS Delhi chapter, which is Arvind Verma Memorial Lecture, where we had the keynote lectures by the experts like Dr. R.K. Bhandari and Dr. G.V. Rao. This is just a glimpse of the event. That time we could all meet in person. So this was the event, when we held it. Apart from that, we also have regular AGMs and award ceremony. This is 2019, where the Lifetime Achievement Awards were given to Dr. D.N. Naresh and Dr. Chandan Ghosh, and Young Engineers Award to Mrs. Parvati. I'm just scanning through some of the slides, which will just give you an overview of what all we are doing at IGS Delhi chapter. And then came the turning point, 2019 to 2020. But initially, we kept our momentum on, and we were arranging field visits. This was a site visit arranged at Dakna Meerut Expressway in association with GR Infrastructure. And this was a very successful field visit. If you can see the pictures here, we could actually see, the work which is going on at the expressway. Then we had arranged for a technical lecture. This was in association with DFI India. We had Mr. James A. Morrison and Mr. Craig Wendella from DFI USA, who spoke on the topic, historical perspective and current state of practice in soft ground tunneling. This is just a glimpse, and you can see Dr. Shahu there and others very attentively listening to the lecture there. We also arranged for another workshop on real-time vibration monitoring at a metro site. This was arranged by AML Limited. This is again a glimpse of all the people who were there at the metro site. But with the onset of coronavirus, a lot of things changed. We could not meet in person, but this could not deter the IGS Delhi chapter. We took the digital route, and we've already arranged for more than 13 events in a year, which includes the lectures, workshops, field visits, virtual events, and webinars, had Indian and international speakers too. This was the AGM and the award ceremony 2020, where the Lifetime Achievement Award was given to Mr. Sanjay Nirmal and the Leadership Award to Dr. Anil Kumar Sinha. These are all the events which happened in the pre-COVID area, period, when we could actually meet up and, attend all the people there, personally meet up. But as I said, COVID did not deter IGS Delhi chapter. These are all the webinars, which we have arranged in 2020 and 21. The IGS Delhi chapter does not have a back office working. There are people like, I'm sure you would like to know who are the people behind the curtain. Behind the curtain, which is the action team there. It is a team of enthusiastic young professionals from different verticals, academia, research institutes, and the industry who have come together for a common cause. A common cause to make IGS Delhi chapter a more vibrant chapter. This is the team in action. I chair the IGS Delhi chapter. We have Dr. Altaf Usmani and Dr. Manna, who's here with us as the co-chairman. Mr. Mohit Jhalani from NHPC as the honorary secretary. Dr. P. Wangla, IIT Delhi as the treasurer. And we have others, Mrs. Atasi Das, Mr. Sharik Khan, and Dr. Pankaj Gupta as the members. But it is not just the executive committee in action. We are all supported by more than 1,200 members who are there to support IGS Delhi chapter activities all the time. We believe in being connected to the people. We use social media, WhatsApp, LinkedIn, Facebook to make people aware of our programs. There are regular newsletters. We also intend to open up some student chapters, and we will shortly be arranging site visits and lectures in person also once Mr. COVID goes away. Yes, we are delighted because IGS Delhi chapter bagged the Best Chapter Award for 2020. That time there were 47 chapters across the nation, and IGS Delhi chapter received the Best Chapter Award. These kind of awards and recognitions, it only motivates us to raise the bar. So far, we have kept IGS Delhi chapter alive and thriving. Our journey continues. So I would request all the members who are here to expand your horizon, expand your network, and also your geotechnical expertise. If you're interested in the membership, please do write to me at rtbhargava@gmail.com or igsdelhichapter@gmail.com. There is also a brochure available which you can download on IGS Delhi chapter and know more about it. So as I said, we all need to learn more about this technology. And to be an expert, we need to listen to the experts. We have the experts lined up here, Dr. J.T. Shahu, Mr. Andres, and Dr. Sunil Basarkar, who will actually help us, as Dr. Manna said, on various topics related to CFA. So all these experts are going to give us wings to our thoughts. They will help you expand your horizon. If I could say it in Hindi, खोल दे पंख मेरे कहता है परिंदा अभी और उड़ान बाकी है जमी नहीं मंजिल मेरी अभी पूरा आसमां बाकी है. So there is a whole lot of things which we need to learn even after this webinar, but let the flight take off. So with this, thank you so much, and that's the end of my presentation. Thank you.
Thank you. Thank you, Mr. Bhargava, for your inspiring lecture and introducing the workshop and as well as the different activities of IGS Delhi chapter. Thank you so much.
Thank you so much. My pleasure.
So now I'll invite Mr. G. Venkata, who is the Director of DFI of India, and who will give the overview of DFI India activities. So Mr. Venkata Prasad is a civil engineer graduate and got 35 years rich experience in L&T handling of multiple assignments in the execution of projects. He got passion for research for construction and real estate industry, and he authored number of articles for leading magazines and presented lecture in multiple conferences and other events. He joined DFI as a director of operations during December 17 and is responsible for strategy building, setting up required organizations, implementation of new technologies, skill program, with work practice, conferences, workshops, etc. So it's a pleasure to invite Mr. G. Venkat Prasad, and I request him to introduce the DFI India. Thank you. So over to Mr. Prasad.
Yeah, thank you, Dr. Manna, for your kind introduction. So DFI India is into multiple activities for advancing geotechnical and foundation practices in India. I'll provide a quick snapshot of the same today. Yeah, about DFI. DFI India is affiliated to DFI USA. DFI USA is in existence since 1971 with a current membership base of about 4,000 and has been contributing for advancements in DIM Foundation. So DFI India was registered as a non-profit company in 2013 and set up full-time office in December 17 for implementing multiple programs. Yeah, DFI got a robust organization to achieve its mission and goals. And Mr. Aniruddhan is the current chairman, and Mr. Mohan Ramanathan is vice chairman. Including them, we have Dr. KSR, past chairman, and myself, which are a part of the DFI board. DFI executive director, Mrs. Teresa, and technical director, Mrs. Mary Ellen, support us at every stage of our journey. And we have 18-member EC team representing multiple stakeholders for providing guidance and direction of for DFI activities. So we have 2 staff with us who report to me for managing the DFI India operation. So presently we have around 233 members. DFI India mission is to enhance the standards of Indian geotechnical and foundation industry, matching with the global best. Its focus areas are new technologies, skill programs, good work practices, student programs, women empowerment, conference, webinars, seminars, and workshops. By following a DFI US philosophy, we identify different initiatives corresponding to above focus areas in a stage-wise manner, set up committees comprising members from multiple stakeholders, and taking the support of DFI and DFI office, India office. These committees will put consistent efforts for advancing the industry. So in this context, I'll present the scope available in various areas of deep foundation industry in India to reach global standards. So in a developed country, it's well organized, highly equipment oriented, more than 40 technologies exist, engineers, operators, technicians are skilled and certified. Whereas in Indian context, is low importance is being given. So 80% of projects are handled by small contractors with no access to advanced technologies and practices. A few technologies exist, and we do not have any mechanism for skilling. So in this backdrop, DFI took up various initiatives which I'll present quickly. So next. Yeah, I will not talk much about the CFA Pile Committee activities because Dr. Basarkar got a detailed presentation on this. Go to the next. Yeah. So to bring one technology, what kind of efforts it will go? So this is an interesting slide, and so we formed a 12-member committee during July 17th, representing by having a representation from all major companies to mention both national and international, and so we identification of trial site, site for the trial piles, conducting soil investigation, development of design and construction documentation, mobilizing funds for doing a trial piles installation and load testing of trial piles. So the whole process took almost 3 years, and so and multiple stakeholders are involved in that. CFA Pile Committee, industry, and the DFI US office and international expert DFI office. So phenomenal efforts go at every stage. So with the 3 years, we could successfully achieve trial pile installation, testing, documentation. Now the next 3 years will be focusing on IS code approval and implementation of this technology in more projects to achieve the presentation. Yeah. And this is another interesting committee, Geotechnical Characterization of Foundation Committee. DFI set up this committee under chairmanship of retired director of and professor of IIT Delhi, Dr. V.S. Raju, to promote good practices relevant to geotechnical investigation job. So today it's acknowledged that many projects are suffering time and cost overruns, contractual issues, and one of the reasons is our inability to implement good geotechnical investigation practice. So that committee goal is to develop and implement skill training programs to cover 4,000 lab technicians currently employed in the industry and also 1,000 field supervisors. So we also have a goal to work with major owners to implement good tender practices for deployment of good geotechnical agencies, well trained to provide desirable performance. The current status is that we signed 5-year MOU with National Academy of Construction, who will set up NABL accredited lab and provide necessary infrastructure for implementation of skill program. So 3 months training program course material is ready for lab technicians, and these programs will commence from 2021 onwards. So here again, a lot of efforts. So more than 2 years, the multiple stakeholders involved in that, and more to be done to achieve their desired goals. Next. The other few programs under the current agenda are that, so we have DFI Chennai Metro International Geotechnical Engineering and Contractual Construction Working Group. So this provides value-based solutions to the Chennai Metro second phase project. And DFI is setting up a specific platform to catering to the student interest. So we have 3 professors from these 3 institutes helping us implementation of these programs. So we have programs to conduct webinar programs, having a technical presentations and professional development programs. So far 3 webinars conducted. So similarly, DFI India Women in Deep Foundation team. So there are a group of dynamic women professionals working for the empowerment of women professionals in India. So we have planned so multiple programs with their support. So already 2 professional development programs are organized. So DFI annual conference are well known in the country, and will be reaching them to more professional through digital and other means to have a best advantage of this program. So last year we launched an educational series program by commencing the first program on steel foundation, and this was well received by industry. We can see more programs and also training programs corresponding to industry soon. And so to address the geotechnical so now it's understood that so many projects are suffering time cost overruns due to geotechnical and foundation issues. So DFI India Platform helped to address these through implementation of new technology skill programs and all, to summarize, they tell in summary format. So there is also a requirement that continuous basis learning is required to address these challenges in the industry. So our knowledge platform, so this conference and workshops, webinar programs will help so enhancing the knowledge levels. So we have journals and publications, so the members and other people can access to know the more knowledge, and by remaining part of various committees also they can contribute substantially lot. Yeah, next. So in nutshell, so all of you, this is not the one-person contribution. So it's the collaborative efforts of multiple stakeholders, and we require more and more members supporting us. So they have a chance to be part of various committees. We have executive committee, so key decision-making body on DFI programs comprising of experts representing multiple stakeholders. So they can be part of technical committees. So they can be a change agent to implement new technology skill programs, all this the other program. So they can be part of conference committees, technical and organization committees, conference session chairs, paper reviewers. So they can also be part of editorial committee, and so there are multiple chances. Even this conference also, so for sponsorships and showcasing their products and all. So we request one and all to be part of this big mission. So please become members, and so we look forward to the support of one and all. So thank you very much.
Dr. Mana, you're mute.
DFI India, and also the philosophy of our DFI organization and the various activities. Thank you very much, sir. So now we'll start the presentation session. So first presentation is by Professor J.P. Shahu, who is Professor of IIT Delhi and also Honorary Secretary of IGS Delhi. So he will talk on pile foundation, difficulties in alluvial soil, and possible way forward. So Dr. J.P. Shahu received his MTech and PhD degree from IIT Kanpur, India in 1988 and 1994. He did his postdoctoral research at Institute of Lowland Technology, Japan in 1996 to 99. His main research interests are transportation geotechniques, ground improvement, geosynthetic applications, and foundation. He has more than 50 papers in international journals and 100 papers in conferences. He has also co-edited 6 books. He was the chairman of IGS Delhi chapter from 2015 to 17 and is the honorary secretary of IGS India Geotechnical Society since 2017. So now I welcome Professor J.P. Shahu and request him to give his presentation. And over to Professor J.P. Shahu.
Is my screen visible now?
Yes, sir. The thank you slide is visible.
Okay. So, yeah, just a moment. I will just go to the beginning. Okay. So, first of all, I must thank the organizers of DFI as well as IGS Delhi chapter for giving me this opportunity. Actually, when Professor Basarkar about a week back contacted me, the first reaction was, oh, hardly time, because material was not ready, presentation was not ready, and to make the presentation from such a hectic schedule was very difficult. But then he said, no, you have to give. So then I had no other alternative, so I had to prepare. But now I understand fully well why he insisted that. It is because I think I was kind of witness to the DFI, this DFI activities, the activities by the members of DFI who conducted CFA pile testing on the alluvial soils. And I was impressed, though I could not witness complete few days because it runs few days, but nevertheless, I think I was the only one from IGS side as well as aware of the locality, aware of the soil type there, aware of the pile foundation there. So I know, knowing the very high standard of the DFI conferences, etc., I was little fearful, but then I jumped into the bandwagon and I said, okay, I will do it. So I thank Professor Basarkar profusely for giving me this opportunity. Then I thank also Mrs. Aarti Bhargav for this opportunity along with Professor Manna. And also I thank other office bearers of DFI for giving me this opportunity. So coming to this presentation, the pile foundation, difficulties in alluvial soils and possible way forward. So essentially we have in alluvial soils, pile foundation is well known, but alluvial soils, that means in Indo-Gangetic plains, large scale application of pile foundation started not few years back, about a decade back. A university was founded in Gautam Buddha Nagar, Gautam Buddha University. At that time, they tried this pile foundation. Unfortunately, they didn't know which type of pile to be used. They started with the driven piles, and halfway it went inside. First of all, for driven pile, they had to bring the equipment, transport it to the Indo-Gangetic plain, Delhi, from Madras. They told me that it took 1 month for that truck-mounted equipment to move to the Delhi. And then it started, and it got stuck after the halfway pile had been driven. So then we went for the ground improvement methods and then constructed the structure. But suffice it to say that that was the kind of a beginning around 2005 or 2006, when this all pile foundation in such a large scale started coming up in Delhi region. And then we are having now multi-story building, 40-story building, 60-story building, which are left and right working on pile foundation. This particular topic, I think, is very instructive for this reason, as you will see later, because in this soil, a lot of intense activity has not been so far, piling activity has not been done so far. And this is a project where it was done very intensely, and I will tell you few of our experiences where we had to look at, wonder why it is happening. So essentially, I am the presenter here, and this project is a very large scale, and it was supported by IT Dissemination, Geodynamics, and others which I would not like to name at present because of the permission issues. So this is the work done. So you can see this is the test setup of this site. The site is very large site, 1 kilometer by 1 kilometer, but this is a small place within this site, and this grids you can see, each grid line is at 20-meter distance. So from here, this was one test site to other test site, it was about 60 to 100 meter away, and from test site to test site 3 was again 60 to 80 meter away. So within this small distances of 100 meter in alluvial gangetic soil, you do not expect too many changes in the soil properties, especially over a very large depth. So this site is present in Haryana, has a alluvial soil, Indo-Gangetic soil, and the soil varies. There is a dense silty sand at depth. You will find that it has clayey silt also, and it also had sandy silt also. So all these soils are present in the ground, and groundwater table is shallow at 2 to 3 meter from ground surface. So with this background, let me first tell you, you can see small circles, etc. are there. These are the places where these tests were carried out. So what are these tests? Total 8 tests I'm going to present here, though many more tests have been conducted, but I will just present 8 tests here, which were of very much importance and suffice my purpose here. So these tests were, as I told you, the soil varied from dense silty sand to sandy silt to clay silt, and these were all initial pile load tests, and they were performed on 1.2 meter dia piles, and this is the pile diameter, and the length of the pile was 36 meter all along. And the test conducted of 3 vertical tests, vertical pile load test VT1, VT2 and VT3, 3 lateral load tests LT1, LT2 and LT3, and 2 high strain tests HS1 and HS2. The test load expected based on the theoretical calculation ultimate load was 2,570 tons for vertical and 300 tons lateral load. And HS test, high strength test, where it was first assumed to be 2.570, but then it was reduced to 1,545. Then if you see that LSIT, which means the low strain pile integrity test, so LSIT tests were conducted on all these piles. Cross-hole sonic logging tests were also conducted on all these piles. These piles were further instrumented with VWSG, that is vibrating wire strain gauges, and at least 3 piles here were instrumented and 1 pile here. Then we also included PTPC pile tape pressure cell in one of the cases, VT1, and inclinometer were present with, of course, LT1, LT2 and LT3. So these were the test summary which we had. Then you can see here, I will just say, first thing is we must go for the bore cast in situ piles in these soils, because N values are not so small that they can be driven easily, and also these are very large dia piles, so there was no alternative at that time. So we had to go for bore cast in situ piles instead of driven piles. So the procedure is shown here. You can see how messy the procedure can get, and please understand that this process has to be spread over a couple of months from the installation of piles, 28 days for strength development, and then you have to do the pile load testing, etc. So it is a time-taking thing. So you have here pile boring by hydraulic rig, and here you can see that we are using the bucket drilling. So this bucket rotates and picks the soil, then it is removed, it is taken out, and then it is removed. So this is what is the drilling method adopted. Then because it is a silty sand kind of soil, so we had to use the bentonite slurry. So this shows the bentonite pond here, and from bentonite pond we were pumping this bentonite into the borehole here, and so then once the borehole has been made, the bentonite level was always kept above the groundwater table level, and all the procedure were perfectly followed as per Indian standard, because project has been of a national importance. So here you can see the reinforcement cage, and this reinforcement cage one of them is being lifted up, and then it is inserted inside the borehole, and I would like your attention towards this spacer block, cover block. Actually, this cover block are there, which are very sharp, round, teethed kind of a block. You can see here. So these are put because they are essential to make the cover. Otherwise, concrete or otherwise reinforcement will be exposed, may be exposed. So that is why cover blocks are kept here. So this process shows the lapping of the reinforcement bars, because these are inserted in stages. First stage it is inserted, then this will be inserted after lapping with the first cage, like that. Then you can see here, the once the cage has been inserted, then tremie pipe is being lowered here. After lowering of the tremie pipe, concrete is being poured through the tremie pipe in a measured quantity, and thus pile is cast. But in between there are many operations. So before you before you insert your gauge, this reinforcement gauge, you have to flush the mug. Take the mug collected at the bottom of the borehole by baler, and then you have to flush that by the bentonite slurry until you get the density of bentonite which is being inserted same as the density of the bentonite which is coming out. So that is also a very messy operation. So this is all whole procedure. So you can see here how messy it is. So this figure shows cage is being lowered. This figure shows fixing of the casing here. Guide casing is being inserted for a few meters here, and then you have the boring here. So all these operations are shown in this one picture. So then after 28 days of strength gain, then these piles are subjected to plate load test, vertical plate load test in this manner. And you can see this reaction pile, anchor piles, these are being connected with the strand high tension wires to this. And then here is a yellow colored jacks here, because loads were 2,500 tons, so 4 jacks were used here. And these are the joists to which this datum bar is connected, etc. And then you know the procedure, and you can see that now this anchor piles have been concreted, and these people are operating remotely. This plate load test is ongoing, and they are operating the hydraulic jack remotely and taking the readings are being taken by this camera, etc. And then there are LVDT, electronic readings also, and various types of readings are being taken. This shows the layout of the lateral pile load test. You can see the 2 pile reaction piles here, and this is test pile, and load is being exerted for lateral pile load test. And you can see the 2 boreholes here where inclinometer has been inserted to measure how much inclination is happening, etc. So this is kind of data we get. So this is inclinometer casing and direction of loading, axis A. Somewhere here also you have another inclinometer casing to axis B. So what is the kind of inclinometer readings you can get? And you can see here the measurements of the displacements of the pile head. So you can measure at different location, and assuming a linear variation, then you can obtain what is the displacement at the cutoff level. So this is the way in which deflection is measured at the pile head. Though this test is not, I'm not going to describe here, but this shows the arrangement for pull-out load test arrangement. Here is a hydraulic jack plate placed at the top instead of at the ground. So now anchor piles are subjected to compressive load, and test pile is is connected with the high tensile strand, and thus they are subjected to uplift forces. So this is the arrangement for pull-out test. Then this shows the arrangement for high strain dynamic test. So you can see a hammer here. So it is a dynamic test. This hammer is is uh, uh, dropped on this anvil. This anvil is there, and here is a pile you can see. So then there are so this is the arrangement for high strain dynamic test. So this is test arrangement shown here. So impact is done by about 1% of the using the hammer of weight less than or equal to or greater than 1% of estimated capacity, and we need to have adjust the fall height such that we get 2 to 3 mm settlement per blow, and readings are taken using accelerometer, and we also attach strain gauges to the pile. The setup is less cumbersome to set up, and force velocity diagram is obtained, which gives you indication of the pile load as well as pile integrity. So analysis in high strain dynamic test is carried out by two ways. One is the PDA and another is the CAPWAP analysis. So PDA is a kind of a on-site program where closed form solution is used to compute pile load capacity from whatever the hammer drop you are applying and the velocity you are recording through accelerometers. Then the values, however, this PDA program measures the value based on assumption that pile is uniform throughout its length, and there is soil which is having the reaction with the pile. That means skin friction is also uniform throughout the length. Also, parameter like quake and damping is assumed in this case. However, for both piles, PDA is not recommended. You have to go for CAPWAP analysis, and CAPWAP analysis it checks, uses the same data which PDA uses, and it uses a lumped mass and spring wave equation model. So this equation, this parameter model it uses, which consists of lump mass and spring wave, and pile, and you assume a pile and soil resistance, and then you reiterate in CAPWAP until you get a good match between the applied forces and the measured forces. So you can get this, you get this kind of a diagram, this kind of a load displacement relationship for the pile with the depth, and pile at the top, and this is at the bottom. So you get the load displacement relationship at the top as well as at the bottom, and then you can summarize the CAPWAP analysis results. For example, here this result says that pile resistance is 650 tons corresponding to this point, then skin friction is 501 ton corresponding to this point, and so on. So you can obtain skin friction, end bearing, and everything using this CAPWAP analysis, which is based on the wave equations. Along with the high strain dynamic test, we can use VWSB, that is vibrating wave strain benches, and PTPC, which is the pile tip pressure cells along the pile. So at each level you will see that 3 to 4 strain gauges are inserted, and for each strain gauge you can measure the strain, and then that strain multiplied by E, material constant E, will give you the stresses. Stresses multiplied by the area will give you the force at this level. So that force you can plot here. So force, for example, at this level, this is the force obtained, and this is the elevation. So this is how you can plot this complete curve. So these curves are, this is at when you apply low load, and then when you apply increase the load, how the load was distributed throughout the depth in this analysis. So essentially you get the load distribution throughout the pile depth, and this also is this is based on the VW, SB and PTPC. So what are the difficulties we encounter in alluvial soils? So basically there are two problems. One is the quality control and quality assurance. So you go in the field, you are driving 100 piles, let us say, but how many of them would be having the same capacity which you are assuming? That is doubtful. That is what I say quality control. And in this case, I feel that that quantity would be large. And why I say so? Because even in this 8 piles, we found that we had a lot of discrepancy. These were control tests with the great supervision, but still we had problems. So imagine a contractor driving the pile over a site. God knows what kind of quality we are having. And the second issue comes with the interpretation of design law, interpretation of the design law. So if you look at the pile integrity test, so I will take a case of VT3 pile, which we had problem with. So if you look at this pile integrity test, which I also said, so we had pile integrity test. So we had pile integrity test, and in the pile integrity test, oh, my screen is coming on my, I don't know. Okay, thanks. So I'm talking about the pile integrity test. So it is one of the very good tools, and this test comprise of this test involve attachment of accelerometer on pile top. After attachment, the impact device, a nylon tipped hammer, generates a low strain compressive wave which travels down the pile. Acceleration and velocity records of the impact along with subsequent reflections from either pile toe or discontinuities are graphically displayed. So this figures compares the good response with the poor response, a typical case. So this is the depth of the pile up to 24 meter. So you can see that if it is a good pile, then toe response would be like this, and this will be completely flat because the compressive wave will travel from this point to this point and then reflect without much loss in energy. On the other hand, in this case, if you have a defect, then this kind of picture will be shown. So this shows the damaged pipe. So in this case, VT3, we had VT3 as well as VT3 old. Two pile testing were done. So in case of VT3 new, we found that we had this kind of trace rather than this kind of sharp trace. And VT3 old, there was no trace present also. So so VT3 old, though this kind of sharp trace was not there, still somehow it was interpreted that is fairly uniform, so okay integrity. But this was completely put under the unacceptable because this doesn't happen. So major defect was evident around 30-meter level in VT3. Oh, what is happening? Okay. So then VT3, we also carried out cross-hole sonic logging test. So in cross-hole sonic logging test, what happens? Uh, we at least we need 3 tubes installed in a drilled shaft prior to pouring the concrete, and the stress pulses from one tube to the other is sent at every 50 millimeter depth, at every 50 millimeter depth. So you can see that here four this tubing were there, 1, 2, 3, 4. So from this tubing you can send the ultraviolet pulses in this direction, in this direction, in this direction. So this stress shows the so this stress is for the ultraviolet pulses from this point to this point. So this is the cross-hole sonic logging test. So here you can see if it is a good kind of a pile, you will have uniform this section. There will be no such defects. So this shows that major defect is present at 4 meter, 5 meter, and then 8 to 8.5 meter in VT3 pile. So this is for the old VT3, where here old VT3 was considered as okay. So even with all these precautions, we are having this kind of problem in integrity. Then we also carried out the test on new VT3, and you can see again there are a lot of kind of a problems here. So major defects were found at several places as listed here. So these are very useful instrument to find out the pile defects. So from this we came to know that old VT3 as well as new VT3 both were defective in spite of having so much quality control. Then we can see even the case of HS2 pile, where this we also carried out vertical load test on this pile, and then first we did the dynamic test, and then in dynamic test it doesn't fail because 1% of the pile capacity hammer of 1% of the pile capacity is used. So after that we also can carry out vertical load test on those piles. So here we did that, and this I have already explained. So you can see that from this we get this kind of picture that you may see here that out of the total load applied, which was around 1400, not 1200, because this is the load at half meter below. Total load applied was 1400, and 1400, and here you have 400 at the bottom. So about 30% load was reaching at the bottom, and the skin friction was taking 70%. But if you notice, you will see that most of this skin friction was taken up within top 6-7 meter, and rest of the 30 meter was not taking much of the load. So why the load is not taken by the skin friction below? That was one of the puzzle, and it looks like this certainly should be a quality control issue. This is VT1 test. So in VT1 test also we had this kind of VWSB and PTPC. Here you can see that out of the total around 1200 tons that was applied, the bottom was getting only 300 ton load. So it was concluded that about 90% was being transferred through skin friction and only 10% by end bearing. You can see that while up to 7-8 meter, most of the load was being distributed, but below there was no load distribution. Where is the skin friction going? We don't know. Is it a quality issue? So, what could be the quality issues? We were very surprised that we are not getting the side resistance. We are not getting the skin friction. So, there could be many problems here. For example, muck cleaning at the bottom. We used the baler and we back flushed it by the bentonite slurry, but still we feel that there is a scope here. It may not be proper. Overcut on the sides. So this figure shows that when you are inserting the cage, especially, what is happening? Probably because of these kind of cover blocks, this may be just or getting overcut, or because of some other issue it is getting overcut. And so when you are pouring the concrete, so this could be the overcut may be happening because of the lowering of the cage or because of the spacer blocks here. There could be also a problem that concrete may not be spreading beyond the reinforcement. That means concrete is remaining here, and this could be because of the low slump, because it was done as per IS code and slump was 150 to 180 mm of the concrete. But reinforcement were too close here, and because heavy load was coming, so it is possible that concrete may not be spreading properly. It is also possible that bentonite may be getting deposited on the sides, and so all this could be the problem. We don't know what is happening inside. So IS code recommends the bentonite should be there, but nowadays we are having the polymers which are serving as the bentonite. So we should think about that. So my probable cause could be why skin friction is not generating beyond 7 meter. Could be one way reason is the concrete is not spreading in this zone at all. That could be one of the reason, but I don't know for sure. Then the second issue is with the interpretation of design load. So if you see, Pranav, how much time do I have now?
Yes, I am about to say, Professor Shahu, that it's at 30 minutes. So, because we have another 10 minutes for the question and answer round to put. So, please try to conclude. Yeah.
Okay. Thank you. So that just give me these 3 slides are important. I will just try to cover. This is very important.
Yes, sir. Please go ahead, sir.
So, SPD N values for 36 meters varied between 28 to greater than 50 from 17 meter onwards. So theoretical capacity, ultimate capacity came, we can calculate 1800 to 2400 tons, 2400 tons based on limiting values. But you can see that if you draw by the Wessex criteria, you will not get more than 1200 ton capacity in these cases. So where this why we are getting only 2/3 capacity? Then high strength dynamic test using CABWAP, if you see, it gives much less ultimate capacity. You get only about 650 and 550 capacity here. So what is happening? Nobody knows why we are not getting the enough capacity generated in these cases, though strict quality control was maintained. Even more puzzling is the safe design load. So if you interpret safe design load as per IS code, if you have a curve in this kind of nature of the curve like this, if it is a dense sand, then safe design load will vary from 480 to 400 tons. If you design by settlement criteria for such curves, then you have to take half of the load corresponding to the settlement of 10% of pile diameter, or 2/3 of the load corresponding to the settlement of 12 mm and lower of the two. So from this criteria, we get only 267 tons safe load. So there is a large variation from 267 to 400 tons, while HST test gives even much less safe load. So what to do in such cases? From this, you get almost half of the 480 tons. So lateral load capacity, we get 260 to 400 tons. There is a range here. So again, interpretation problem here. So which one will we adopt? And this is not the case only for this side. I can show you a case for the pile raft foundation system in Noida for 45-story tower near sector 129 in Noida. These piles were also 1 meter pile, and 3 pile load tests were conducted. So these piles were 33 meter length, 2 piles, and one was 38 meter in length. So this is the interpretation corresponding to, we have to obtain spring constant for the design of pile raft foundation. And for that, you can see that 2 piles are showing this behavior, 1 pile is showing this behavior. Which one we can take for such 48-story building? So if you, based on the 25 mm settlement you calculate, you will get 2.5 lakh kilonewton per meter stiffness, and you will also get 6 lakh kilonewton per meter stiffness. So almost we are designing oversafe by margin of 2. And a possible way forward is continuous flight auger, it seems. So simply speaking, the procedure is shown here. You can refer that, and more speaker will be speaking on this. So this figure shows the test carried out at this site, where this is a hollow auger which is being used, and as this hollow auger advances, soil comes out automatically. It travels upward through the blades of the auger and comes out. You can see this spacer block, which cover block. This is what I was referring to. And then after this soil comes out, when you reach the foundation depth, then you can pour the concrete. This concrete pouring operation is going on. After pouring of the concrete, you have to insert this reinforcement cage. And after inserting the reinforcement cage, then like this, and then you can cast the pile, and you can chip the extra head of the pile. So this is the complete procedure of the CFA pile construction. And the fact that the hollow stem auger provides support to the excavated shaft at all times during the drilling process precludes the need for temporary casings or bentonite slurry and associated quality problems. There is no risk of improper cleaning of borehole base also here. There is no risk of improper spreading of concrete also there. But still, I think DFI has constituted a committee which is looking into this research aspect. More research aspect is needed, because here workability of concrete needs to be high. I think slump of 600 is needed, 600 mm is needed here minimum, while IS code recommends 150 to 180 mm. So this needs more research, so that there is no loss of strength in the Indian conditions. So, and you have to have the workable concrete, as well as there should be no loss of strength. So more research in this field is needed. And also we have to look into the cost aspect. How does it compare with other methods? So this is the summary of my presentation. And I think most of the issue I have covered. So, but I will just repeat. Pile consistency in alluvial soil appears to be difficult for board cast in situ piles, and this leads to to low end bearing and low skin friction. Alluvial deposit with little percentage of clay content appears to pose serious problems of quality control. Interpretation is also changing from such data, and CFA looks like a possible way forward, but a little more research or study is needed for its use in Indian conditions. Thank you.
Thank you very much, Professor J.T. Shahu, for your wonderful presentation, very informative. So now we already start getting some questions. So I received a question from Mr. Venkataraman Balakumar, though he has not mentioned his organization. So his first question is that in the SAP stress distribution plot, it is seen that the stress reduces with depth, then it increases up to a depth and then again decreases. Can this behavior be explained? This is the first question. And second question is that was there any background?
One by one.
Okay, fine.
Yeah, so basically it happens because of the instrumentation problem, because when you do the instrumentation, even with the best of the instrumentation, you will have some fluctuation. So based on the sensitivity of the strain gauges also, when you convert that into the force data, basically essentially it indicates that it is a kind of a uniform, you are getting the load.
Okay.
So basically it is an instrumentation problem. It is an instrumentation fluctuation problem.
I think if there is any further doubt, that will directly write to Professor Shahu or the presenter, who will have more discussion later on. And I'm just reading the second question asked by the same Mr. Balakumar. He's asking, was there any back analysis done using the pile soil stiffness obtained from the load test?
Please, could you repeat that question?
Was there any back analysis done using the pile soil stiffness obtained from the load test?
You mean soil is your voice is breaking, Professor Manna. I'm sorry.
He's asking, was there any back analysis done using the pile soil stiffness obtained from the load test?
Back analysis done using
The pile soil stiffness.
Yes. So we did the batch analysis, and from that, based on that only, we know that it will be around 1800 to 2400 our load should be, but we are getting only less than 1200.
Okay, fine. Now next question by Umar Shankar from IIT Hyderabad. He's saying, nice talk. What percentage of the pile installed showed no defects in them?
Oh, okay. That is very good question. Good question. So out of 9 pile, almost like 3 piles were having the problems. So that you can interpret 30% almost with the strict quality control.
Then is just a comments by Dr. M.M. Yunus Ali. Thanks a lot for your excellent presentation. And then there is another question by Mr. Arun Chatterjee from LNT. Who is asking how the reinforcement can be inserted after concreting. As concrete was set, what about cleaning of board?
In which case, CFA or in CFA, it has to be inserted after concrete. You have poured the concrete. In this case, in board cast in situ pile, no. You have to first insert the reinforcement because concrete will harden. Then you can't.
Okay. And what about the cleaning of board?
Yeah.
Okay. Then next question by Abu Dhabi. He's asking, in PIT test at 4, I am getting flat response. What is remedies should I take?
What is the first part of the question?
In PIT test at 4, I am getting flat response. What is remedies should I take?
थोड़ा प्रॉब्लम है.
I think, sir, you can
Microphone
see
में
also in your chat box. You can also see in your chat box or in a questions link that question also that presenter can see. He said in PIT test at 2, I am getting flat response. What is remedy should I take?
in PIT test you are getting what you are getting?
Flat response. At the core, he is getting flat response and he is asking what are the remedies should I take?
Oh, he is getting fat loss.
Flat response, no toe reflection. He said he is not getting any toe reflection, he is getting the flat response. So what the remedies should be taken?
So I think it has to be interpreted properly. It has to be interpreted properly. It should show a distinct peak. If it is not showing distinct peak, then it shows a probable case of defect. I do not know.
Yeah, I think some software, it can be amplified. The response can be amplified, and it has been told that if you are not getting the toe response, you try to amplify it, where you can see the toe reflection. Sometimes some software told like that. So I'm just sharing my experience as well. So the next question is asked by Puneet. Can you use the self-compacting concrete for workability aspect?
In both piles, you mean?
In your presentation, rest of your presentation, he is asking that can he use the self-compacting concrete for workability aspect?
Well, self-compacting concrete, use of self-compacting concrete in case of board piles, it's a very tedious process. I don't think that has been done before.
Okay. I think this is the last question by Mr. Bhavin Mara. He is asking what bentonite quality is preferable in piling?
So about bentonite quality, there is a clear Indian standard instruction are there in 2912, I think that is the code. So you can go through that bentonite complete 2 pages recommendations are there about the bentonite quality.
Okay, thank you, sir. I don't think any other question left. So I almost addressed all the questions. Yes, no other questions left, sir. So thank you very much, Professor Shahu, for your talk and addressing all the queries asked by the attendees. And thank you so much for your wonderful presentation.
You are welcome. Thank you.
Okay, fine. So we'll now come for the second presentation. So second presentation will be given by Mr. Andres Baquerizo. He will talk on world case studies on CFA piles from a typical project to an extreme application. Mr. Andres is a licensed professional engineer in state of Florida, USA. South America with more than 25 years of design build experience. In 2002, Mr. Andres joined HF Foundation and just hold on. Okay. rising through the ranks and becoming the director of engineering and vice president. He successfully completed more than 1,200 projects, including auger and displacement piling, tangent bearing elements, microcompaction, excavation, shoring, and bottom plugs, chemical soil mix, jet ground, tree mixtures across the nation. In 2019, Mr. Andres was awarded the AFC National Rebuilding Award. So I request Mr. Andres to start his presentation.
Thank you very much. I hope you can hear me well. We'll go through a CFA review at that point. I'll try to catch up a little bit of the time as we are going a little bit longer in that sense. We're going to review some basic techniques, some pros and cons of the CFA or gas piles, some equipment reviews, some challenges, and then some project summaries. In the basic techniques, as explained before in the previous presenter, it is a way to be able to transmit loads from a higher elevation to a lower stratum that can just support the loads by reducing the settlement or minimizing the settlement, and of course carrying the vertical loads. Is in basic kind of a theory. With that, you can see there are different lengths and sizes of piles that have been used, but in general terms, as you go, you end up getting an auger that is being installed in the ground, no casing, going through different soils, clay, silts, sands, cohesion or cohesionless. We need those soils to be more than weight of hammer though. The drilling will take the spoils out of the hole excavation. The hole will not be perfect. It will have rugosity into it, and then we're going to go into the bearing stratum in that point. At that stage, grout will be poured on the bottom, called the head of pressure, and this head of pressure is designed so when we begin to remove the auger, the pressure of the soil trying to push the soil inside and make it collapse, it will be supported by the head of pressure of the grout, which is heavier in density than typical soils. That means that a calculation has to be made to see how much pressure or how much head of grout is being pumped at the bottom. 5 feet, call it 2 meters, 3 meters, 4 meters, to be able to compensate for that kind of lateral pressure. When that is the case, then removal of the auger is being done and additional grout is being provided through it, leaving the hole open and then completely stable through that equalized pressure of hydraulic in between the inside grout to the external soil. You cannot take that much time for the next process that is dropping the steel in, because the more time it passes, the more density the bottom of the auger is going to get, right? The self weight of the material is extruding the water outside of the particles, and by extruding the water outside of the mix, it becomes denser. So there's a couple of minutes between the completion of a pile and the installation of the cage that should be performed. That reinforcing can be done with reinforcing cages. It can be done with beams, I-beams, pipes, or so on. In some different parts of the world, a full cage to the bottom of the hole is requested to verify that the hole has been completely installed and is fully open, verifying that the shaft is complete, the integrity is complete. In other parts of the world, they are okay with just having reinforcing on the upper portion of that pile, just the upper third of the pile. So it depends on the codes and regulations of local. This picture on the left is in Miami, Florida. A full reinforcing cage is being installed from top to bottom to be able to get tension loads. And as you can see, this is a 30+ meter pile, about 34 meters and 700 millimeters in diameter, or 30 inches for the ones that are looking into different units. As I said, shorter cages can be installed. With that being said, what is kind of soils that the CFA can be installed? So CFA can install in almost all kind of soils, as the drilling of the system is depends really on the capacity of the drill rig and the teeth or configuration of that bit on the bottom. If you think about when you have your hand drill and you're doing holes at home to hang something on your wall, if you end up having a wood drill, it cannot drill through metal or masonry. So you have to have the right bit at the bottom to be able to have an penetrate the material that you're trying to penetrate. In this case, it's similar. You may have a really powerful rig and a super powerful torque on it, but if you don't have the right design on the tip of that auger, it will not be adequate. So really important to feel that even though we can go through all types of materials and soils at that point, we cannot have anything that is weight of hammer material, because if the soils on the side of the shaft are too weak, when the grout is being placed in and has more pressure and density than the soils outside, it will just start to expand out and collapse the hole. So weight of hammer materials are really difficult to address, and of course refusal boulder materials when you're testing the soils. Anything in between of that end up being performed at a CFA. Now, the question is not that can it be done, the question is should it be done? And so it really depends in different areas, the availability of equipment or capability of local teams, if they can get into those kind of soils. It is a really good tool to be able to, a technique to install it in most cases, but it should be compared to local experience, because if you have a really hard, dense limestone rock kind of at the bottom of the hole, and you're going to have a really good end bearing, probably shaft is a good solution. If you can erode and get into it and drill it through, the CFA is a great solution. Now, rocks, as you can see on the right side, are perfect. This type of rocks that is on the right side are perfect for CFA, because when you drill your pile into it, as you can see in the upper picture, you're going to create this cylinder on it, and all these little holes are going to get filled with the mix. The cement is going to go into all these little holes, getting a really good friction addition. So instead of having bentonite or polymers filling those holes and then just pouring concrete like an bored shaft pile, what we have is our cement, our concrete flowing into those rocks, getting that friction. And that's why in this type of rock, the CFA gets better friction capacity than the typical bore piles. What are some pros and cons on the project? So pros is we end up having really low vibration and noise. As not being an impact pile being installed or not vibration to be installed is really low vibration, which is really good to be really close to buildings or urban settings. It can be adapted to different lengths. So there are areas in the world where the bearing layer is not as precise as shown here, right? It has changing elevations and depths and so on. So having the ability to install piles that are deeper or shorter in different areas of the project allows you to adapt that pile to exactly what you need, and then use the reinforcing to that condition. You don't have to over-order pile lengths like in precast piles, install them and cut them off, because you can adapt the lengths to the actual bearing that you're looking for. And it's a really fast installation. So these are really pro condition for the CFA, but it's also a con, because it is a fast installation to make it cost effective. And therefore, if the area is not going to allow a fast installation, the cost beneficials may not be there. We'll see in a second. So some of the benefits, we can drill really close to metro movers, really close to buildings with no issues, because there's no vibrations, there's no kind of conditions of such to damage the neighboring buildings, impacts and vibrations. It can get lateral loads by the vertical analysis. Just having a plumb pile has a lot of vertical capacity, but it can also be installed in this angle, like you see in the screen. There's a batter pile, getting that lateral load capacity, so you can actually install them in both sides of that cap and be able to get that lateral capacity that in some cases on the porch or buildings is requested. This picture on the right is on the Poland port, and this picture on the left is in the Miami port. Some of the disadvantages at that point are ground conditions, as I mentioned it. When you have really soft soils, you're going to have large material intakes, and make it not cost effective. If you have a soil that is soft soil over hard soil and really hard soil, when you're drilling, if you spend too much time trying to drill the hard soil, the more time you spend drilling the hard soil, the soft soil is collapsing a little bit into a hole, and so you're creating a bigger volume. It's not bad for capacity, but of course, not great for kind of material usage. So we can go through the areas of a hard material, soft material, hard material, and when we pump it, you're going to end up having a pile that is larger in that area, which is not bad. That's a great pile in that behalf. But if you end up doing an analysis like a PDA testing or a PIT test, where you end up impacting the pile to try to get the wave resonance, the analysis of that may show that this pile is too narrow, when in reality, this may be true diameter of the pile because it's rock. So the auger will command the true diameter, but the analysis is going to show this big element down below. So it depends how the analysis is done. It has to be compared to the geotechnical report to verify where the materials were installed in addition. If we install a typical pile to the ground, you're going to get to a bearing layer and install your pile. But if you install a pile that you have boulders on and you hit a boulder that is super refusal hard material, it's going to stop your pile short of the desired location. Drilling through boulders is not a possibility in most CFA conditions. The other one at that point, that being if you have reduced quantity of piles. So when you have a pile cap, the idea of the CFA is to be able to install many piles on the same day. But if you realize on a job like this, you may have to install your first pile, second pile, and third pile. That will be your first day. Then the next day, you're going to be able to install these 4 piles. And the reason for that is because you have to keep at least a certain amount of distance between the fresh grouted pile to the new pile being drilled to not connect them and be able to get this material into this pile. So now the next day you're going to do the next section of piles. But if you think what I'm trying to portray is that the first day you can install 3 elements, the second day you can install 4. If your equipment is capable of installing 30 elements a day, like we have some that we can install 50 and 60 piles in a single day, then if you only have access to 4 piles, the cost of those 4 piles will be greater. So it's a great solution when you have multiple caps, multiple of these settings, that you can install piles in one, jump to a different location, install piles in those, jump to a different location. So it's a great solution, and it's cost effective, and it's more cost effective when we have more piles than only one location to install. That way the day is used to install many elements, not only 2 or 3. The other one is you require really good grout service. Is something that, because you have drilled a hole and you need to start pumping material into it, grout or concrete service in the pile, then you cannot remove your auger until you actually can cast it. On the bore piles, you can drill your piles, put bentonite and polymers, and keep moving and create 2 or 3 holes and then pour them all. On these ones, you have to fill the hole to be able to get the tool out of the ground. So if you don't have good plants or concrete surface in the area, it may be difficult to get a good amount of piles in the ground. And because we're testing the piles like anything else, you need a really good testing labs and technicians to verify that the material is done correctly. What kind of equipment do we use for these kind of elements? We end up using fixed lead machines, like you saw on the previous presenter, right? Fixed lead because the lead of the auger is attached to the rig and they go around. They're really good because they have grout. You can pull the winch in the mast of this rig and be able to get a lot of force into the auger to be able to expedite the drilling. The challenge that they have is that they have to get really close to the hole. As you can see, you're drilling right in front of your pile, so the working pad becomes really important. On the other hand, when we have this type of setting, even though it's attached on the top, you have a certain distance from the rig to the leads, creating that possibility to not have pristine location at the bottom, but still be able to install your piles. The other type of equipment that we end up being what we call the hanging leads. And the hanging leads is because it's just, as you can see, there's no connection between the leads and the crane. It's super easy to transport because the only thing you're transporting across the state or across the country is just this setting, while you can rent the cranes on the local place. That is really beneficial when you're traveling far away from urban areas in that behalf. It can also allow you to drill deeper piles because you can have a bigger crane in that. Normally, the fixed lead equipment is limited to about 30, 35 meters. There are new rigs, the Fundex, that they can drill up to 50 meters, while the hanging leads have been able to get to 55 and 60 meters in that behalf. So we had a previous record of 177 feet, about 52, 53 meters. With this setting and with the attached lead, we were able to get 55 meters. Different settings, as I said, we can drill really close to helixes. This is on a stadium that is being drilled, shallow foundation supported, and we can drill the piles pretty close without affecting its foundations. The typical testing, as presented before, and that being a compression setup, there are different ways to set it up. We prefer to have 4 reactions per each one to make it stable, and then you're going to run your load test. In the tension setup is similar. It's going to be 4 reactions, and then you're going to be pulling on your pile to get the tension load, and you can run lateral load test using 2 piles against 1 to push it and measure deflections on that element. That is typical for most North American markets, where you have to run a load test for every project you install. In some areas of Europe and Australia, if you have local experience and you're signing and sealing, you may be able to design and just install the piles based on that theoretical analysis, not necessarily running a load test. There's also bidirectional testing. This bidirectional testing that we have in these locations end up being a different way to get to higher loads. So instead of having what we call a top-down test, like you see on the previous slide, the load is being imparted at the top of the pile and push the pile into the ground to load test its capacity. If the pile is really deep, 30 meters, and you want to test the bottom layers to make sure that the load is not being dissipated on the upper portion, and most of the load is going to go right at the layer you're testing, you can install what is called an O-cell test in most locations, and now there are new suppliers that also provide them. It's hydraulic jacks that are embedded into the pile, and they use the upper portion of the pile as the reaction for the bottom portion of the pile, and you save all the testing frame. It has to have the right equilibrium of soils to be able to get enough loads to be able to test. On the QA/QC that is being evolved, it has been evolving, we end up having the inspectors on the site to be able to review and certify that everything is done correctly. Now, with the use of computers, that inspector can have also a iPad or similar handheld device to be able to get the readings from the equipment and verify what's going on. So we have flow meters that's going to measure how much material we installing and what depths. Total material installed is the red line. Material per every foot or every meter is measured here. What was the pressure when installing it? If the speed of installation was fast or slow when we're pumping that, and that translates to quality. Now, one important aspect is we can measure more or less what is the speed of installation, and we can correlate this speed of installation to the soil report. Is hard soils or soft soils what we're getting through? All that has, of course, computerized systems in the cabin where the operator can see them and be guided to know if he's doing a good job on that pile or he has to recast. That same can be seen from an inspector on the site as everything is transmitted via Wi-Fi or Bluetooth to that element. The reinforcing, as we saw, are kind of cages that are installed. In most areas, we request the cages to be tapered on the bottom. That way, it's going to guide that cage into position with spacers on the sides. It can be used with beams right, to be able to create walls or support of excavations, or it can be done with pipes, deep pipes installed in the pile after casting. We'll jump into a typical project. So this is a 12-story luxury hotel in Georgia, United States. The piles were supposed to be 16-inch piles up to about 119 feet deep. That is about 35 meters or so depth in the piles. 180 tons with piles installed to refusal kind of weather rocked. This is like a limestone condition that is in that area. And many of the piles were going to be battered to be able to support that lateral loads that they had. So they had wind loads and lateral loads, and some 58 piles were going to be in a 1 and 6 degree batters to be able to get that. This is the soils that you see in values of 36 to 24, a little bit softer in the bottom. The partial weather rock was about on this elevation, so even though it was low values of weather rock, it had really good friction on it to be able to get the corresponding loads. Setup of a project as it's going, flowing. So the nice thing, as we saw on previous slides, is that the system can be cleaner if enough excavators are being done to be able to be removing the spoils as you are drilling, but it can be a clean system. That way, some areas can be released to the next trade. And so as the work progresses in this way, moving to this direction, the next trade can be mobilized and start putting the pile caps behind the rig. There's a picture of installing the piles on a battered condition to be able to get those lateral loads on the shear walls. Close to buildings, no impact conditions. Seems that my presentation missed a slide. On the slide that I'm missing, I had a slide showing the use of strain gauges as shown by the previous presenter. Therefore, when we run the load test, those strain gauges were able to graph out where the load is being dissipated and where the friction is being dissipated in the soil, and verify that the pile on the bottom 2 strain gauges was getting no load. So all the load was being held on the upper strain gauges, and therefore the pile was able to be shortened and getting some savings to the owner through a load test. So if you're running a pile and you think you don't know if you should design a pile that is 30 or 32 meters long or 33 meters long, the load test could be done in the longer length, 33, 35 meters, install the strain gauges, and then verify where the load is being dissipated. Therefore, the bottom portion of the pile can be eliminated for the production piles. A more extreme case, in this case, we have a project in downtown Miami. In this project in downtown Miami, there are different layers of limestone, sand, kind of sandstone, intermediate in between them. The new MET system was going to be installed, MET 1, 2, 3, and it's square. And this 74-story tower and 47 stories was going to be on the high end of buildings at that time frame. And so most people believe that it had to be done with bore piles, and the CFA could not or should not take those loads. There was a value engineering being presented to do it with the CFA or gas piles, and it resulted in a world record test of 5,200 tons in that single pile installed through the OSO. So the project was actually designed simultaneously in bore piles and in CFA or gas piles. And in those bore piles and CFA piles, you can see them on this graph, where the original design was based on the red 6-foot diameter drill shafts, about 48 meters or so long, with the shear wall to support all the tower. Then a second system was designed to say, okay, what could be the comparable if CFA was used? So even though it was almost twice the amount of elements being installed on the ground, the savings of the time was immense. The drill shaft bore piles were needing 250 days to install their system, while the R-gas piles needed 70 days to install the system. The savings of 180 days on a schedule implied multi-million savings on the financial cost of the project. The developers typically are financing these projects, and when they finance these projects, there is a cost for every day that they have this money. So 180 days savings on the schedule was drastic. In addition to that, the direct cost implication had another $3.5 million in savings directly in between comparing the two proposals. If we add that to the 180 days, it was more than $10 million in savings for that specific project. Now, a project in Australia, there was different projects being done, installed already in the background and begin to grow. The new project was already moving in this direction. All this is being completely redone on the river with a nice, beautiful kind of settings of homes overlooking the river. And then new projects are beginning to be designed. So a total project was being envisioned. The previous one had been done with the R-gas piles here, but bore piles there, and this one was in question to see what to do for that one. A Fundex kind of 350 was 355s were projects that were used, and rigs, I'm sorry, equipment that was used to install the process. Two of them was used at the same time. You can see the amount of spoils can be manageable if done correctly. The cages for that specific project, even though the piles were going to be deep enough, at that point, the depth of pile was going to be 52 meters. The reinforcing was only up on the upper fourth or third of that pile by local design codes. Soil were very dense on the top at that point, so some soft to firm layers, and then getting to a really highly moderate weather kind of malleable formation to be able to get that capacity. So even though when you run a load test, you may be able to get most of your capacity on the Werribee formation, the challenge for settlement was too much, and the reduction to minimize that settlement, it was decided to go all the piles into the Melbourne formation to be able to distribute that load more accordingly. So that is the ideal depth at that point, even though it's a really high strength siltstone. 5 MPa is really difficult to drill. 10 MPa is a lot of effort and kind of wear and tear of the tools to be able to go through that material. So most of it was able to get just there and sit on top of it because the capacity was being provided by the upper layers, while the settlement was just kind of terminated at that depth. Some of the layout on that project, some columns supporting one single element, some others and multiple ones. They did have a distribution of larger caps that you see, kind of, and then there was a proposal to reduce that spacing to be able to get a more tighter formation and less punch and shear on the caps. Through a load test being performed, it was proven that that distance in between the installed piles was going to be sufficient and will save time by not having to build a larger cap on top of them. Of course, the key challenges was the past experience with the projects next doors had not been great on the board piles for that area, as the rock formations while drilling with bentonite was losing all the bentonite and having issues dropping kind of their hydraulic kind of passive resistance, and they decided to move into CFA, testing in different depths across the site and asking us to mobilize the load in more than 10 to 50% the test load to accept the piles. I really thank you for the time. I moved a little quickly as I was trying to make up for the time we had at this point, and I kind of open for questions. Thank you.
Thank you very much, Mr. Anders, for your nice and very crisp presentation. So now we can take up the questions. Yeah, I received few questions. So yes. Let me see. Yes, first question being asked by Professor Manoj Prasad. He's asking the main problem in CFA piles can be vertical installment of the reinforcement of large length after concreting is in position. Please comment.
So that is true. Kind of one of the key elements to have a quality CFA pile is to actually be able to insert the cage after pumping. As you saw in the presentation, you drill down, you pump the material, and then you insert the pile. In some places of the world, vibrators are attached to the cage to vibrate the cage into position. In other places like North America, you cannot use the vibrators, and so the stability of that mix during that process is important. So having performed material testing before the project is done to verify two things: that your initial setting allows you enough time to be able to insert the cage, and that enough fluidity is in that mix to allow the cage to be installed. So there are parameters about when you test the material to see how much they flow through a flow meter to a flow cone, how much the spread is in that behalf. But a good design of the mix will be required to be able to have good quality and provide the fluidity and conditions to be able to insert that cage. Most of developed areas have no issues with that element, but it's one of the key quality controls to break through to be able to insert a technique into a new region.
Okay, thank you. This question is by Mr. Vinod Kumar from Afcons Infrastructure Limited. He's writing, I am currently working with CFA piles with reinforcement called rigid inclusion. I am facing difficulties to maintain the cutoff level from before working platform. Let's say working platform is at plus 4 meter and my CFA pile cutoff level is at plus 1.5 meter. The concrete flow sensor is fixed on the top of the organ. So I have to be very careful to calculate the volume of the
So the on rigid inclusions, it's a technique that uses the CFA process to be able to install a concreted element to densify or transmit those loads on top without reinforcing. It's similar to the CFA pile where when you install the element, if you have soft soils down below and you have installed your pile, through time, because the grout or concrete is denser, is going to start pushing these soft soils to kind of to the sides of the pile, engorging the pile, and therefore the volume of the concrete may drop. So it is always better to provide a little bit higher installation the day of the pour and then cut them off, unless you have had a really good clays or dense soils that are not going to begin to take more volume of pile after installation. As you mentioned, the amount of grout being pumped, there's two ways to do it: is through the flow meter and through the actual volume by its strokes being installed to know how much level has been performed. In some cases of different parts of the country for rigid inclusions, what they do have is they have a skid steer, a mini excavator with a mini auger on top of it. So when they over pour the rigid inclusion, they will get the skid steer and re-drill that upper portion of that element after a couple of minutes before it gets set up, but when it's already getting a little bit of density. That way you don't have to do the manual labor of cutting it off, but to try to pour a pile specifically and exactly in an elevation without having any drop off because of that taking of grout on the soil is really difficult or close to impossible.
So I actually, due to some technical issues, I can't read the remaining part of his question being asked by Mr. Vinod Kumar from India. So finally, he's asking that, so I have to be very careful to calculate the volume of the concrete from the step of the roller to avoid the excess cutoff level, but I always fail to maintain the excess cutoff level. So is there any solution to maintain the cutoff level? So that is his complete question. So if it is already being answered, then it's okay. Or if you want to make further comments, so please you can.
The key on the working platform, and it's really important. The working platform is one of the key elements to make sure the equipment is not going to top off. when you have drilled your pile, if that section of the pile is not filled with concrete or grout, it's going to try to cave in. So how the working platform is being performed to make sure that if you stop short, that is not going to cave in and create inclusions is key to that behalf. There are not that many solutions available at this point besides getting it a little bit higher and then trimming to actual elevation.
Next question is by Professor Umar Shankar from IIT Hyderabad. He's saying very informative talk. Do we need to take any extra precaution if we are installing CFA piles in high water table area? For example, the Miami site that he had shown.
So not really. So when you have a high water table, let's say you have a working rate and within a meter or half a meter, you end up having your water table in that location and you're drilling your pile. One of the key elements is to make sure that when you're pumping your pile, the grout gets to the working rate. That way the hydrostatic pressure of the mix is going to maintain the water out. The water actually is helping because at that point it's going to help to hydrate the mix. So instead of being a dry soil, they're going to try to remove the water from your mix and make it too dense to insert the cage. The water is actually helping. Now, you have to verify that water is clean. If you have contaminated water, it can be an issue in that location. But more importantly, is not about if you have high water table, is if you end up having one of those positive kind of rising waters. So there are locations when you end up drilling through a layer and you have a trapped layer of water running river underground, and when you poke through, the water is going to try to come through your pile. So if you have more pressure in that lower layer that's going to try to come through your pile, it may wash out your cement. So high water table, beach areas, and that is not a concern. Kind of 80% of all the Miami buildings are in CFA piles around the beach and the downtown. So there's no concerns about high water tables.
So next question by Mr. Abhishek Jain is asking, is there a limitation on pile diameter for some of the deeper piles greater than 30 meters?
I didn't catch all that, but I think you were talking about if there's a limit to depth about diameter of pile, right? So the piles ranges in depth, in diameter, as you saw, from 300 millimeters all the way up to 1200 millimeters. Now, the deeper, the bigger diameter of the pile has not only a bigger load that has to be drilled into the ground, but in addition to that, you have to have enough torque to break the friction of that bigger element through the soil. So the relationship of the equipment to the diameter is really important to verify that you have enough torque to rotate that tool into the ground at the same time to have enough pressure to go down. Now the equipment, not only that, when you have drilled, as you have a full auger, continuous auger into the ground, when you reach the bottom, and you're going to start to remove that auger out of the ground, rotating, a full blading full of soil. So the equipment has to have enough capacity on the winch to pull that whole element out while it's pumping the concrete and grout. So the relationship diameter to the pile and depth has to do a lot with the capacity of the equipment that is going to be used to have enough drilling torque and winch power to be able to drill down and then to pull that equipment out of the ground.
Okay. Mr. He's from Arcadis. He's asking, what is the maximum depth of pile that can be achieved through CFA? Is it same as the board piles?
What is the maximum depth, you said?
Yes.
Your microphone is a little bit kind of blurry. So
yes.
So we have drill piles all the way up to 1,000 millimeters and 1,200 millimeters. The 1,200 millimeters was installed to 33 meters. The 1,000 millimeters was installed all the way down to 56 meters in that we have. So the equipments, of course, were large enough to withstand that. Anything past 1,000 millimeters is typically a fixed lead machine to be able to have enough power to do so.
Then again, Professor Manoj Datta, he's asking to comment on 3 of his queries. So first query is how to install reinforcement to large depth after ground has been filled to the top.
So I'm trying to read them because I don't know what is going on.
Okay, Professor Datta is asking, he has 3 queries. First, he's asking how to install reinforcement to large depth after ground has been filled to the top.
So at that point, when we design our mixes end up being fluid enough to maintain that viscosity. So the cage is just being installed by its own weight in North America. In Australia and in Europe, is being installed by vibration. So the cage is being erected into the air with a vibrating hammer on the cage, and the cage is being vibrated as being installed into the ground. To maintain the verticality at that point, all the cages end up having spacers, and those spacers are attached to the edges of the cage and has a specific spacing in between them, about 5 meters in between layers of spacers, to guarantee that when the cage is getting down, if it's hitting the side, it's going to bounce into the middle. So it's going to have spacers on the side. Depending on the part of the world that you're working on, they will allow the cage to be tapered at the bottom, so it's easier to install through the ground. In other cases, they want the cage to be perfectly round. I prefer for them to be tapered because a round cage on the bottom can easily, when it's going down into the ground, it could snag soils and pull it into the hole. So a little bit of a taper to guarantee that the bottom of the cage is not dragging on the sides of the soil and it's actually in the middle, it will be really helpful.
The second question is, how is verticality of the reinforcement maintained?
So that I already respond that with the spacers. So because it's hanging in the air, it's going to be by gravity, it's going to be plumb, and it's going down, the spacers will get them in the right place. Now, the third question, that is, how does the soil get stuck in between the flight of the augers? When you have clayey soils, really cohesion soils, they will attempt to get stuck into the flighting, and so an additional system has to be done to be able to provide that flow. Sometimes when you're drilling, you need to be pumping water through your auger to make it fluidable enough that the cuttings are going and flowing above. By safety, on the top of the working grade, there should be an auger cleaner. So when the auger is going through the cleaner, any soil that is there is going to be hitting that auger cleaner and be able to get out. So there are cases where if you take too long drilling a pile, the auger gets really hot and it will get that soil attached to the flighting really dense and stuck to it. That has to be reviewed in a case-by-case basis.
So as we are running out of the time, so I would like to invite the third presenter, but whatever the question being asked and few questions are still remaining. So DFI will put forward all the queries to Mr. Anders and we will get back your answer. I think the DFI will make some arrangement because we are already running out of time. So I would like to thank Mr. Anders for this presentation, and I would like to call the third presenter. Thank you very much, Mr. Anders. So our third presentation is on CFA Piles, design approach, suitability and application in India. I'd like to introduce Mr. Sunil Basarkar. He is basically the General Manager, Afcons Infrastructure Limited, Mumbai, Chair, DFI CFA Pile Technology Implementation Committee. Dr. Sunil Basarkar is Head of Geotechnical Engineering Department at Afcons Infrastructure Limited, Mumbai. He has a total experience of about 17 years in the field and 16 years association with academia in area of geotechnical engineering. Dr. Basarkar has published more than 50 papers in various national and international conferences and reputed journals. He is an executive committee member of DFI of India. Dr. Basarkar is a nominated member from the IGS for International Committee for Land Reclamation. He has also fellow of Institution of Engineers, India, Indian Geotechnical Society, Institute of Bridge Engineering. Dr. Basarkar also served as an editor of DFI Journal USA. So I welcome Dr. Basarkar and I request him to start his presentation.
The organizers for giving me the chance for the presentation. Thanks to Professor Manna for kind words of introduction. Time is short and I believe we are short by another 20 minutes. So I'll be making best attempt to make my presentation as fast as possible. So welcome all. I come to the type of piles which are normally used and popular in India. One is the board cast in situ pile, which occupies about 70% of application. Driven cast in situ pile with 15 to 20% application. Driven precast pile, in fact, with 15 to 20% application. And driven cast in situ pile with 10 to 15% application. And yes, there are a huge scope of application for the contiguous flight agar pile. They are not executed presently in India. If you see this pie chart, you will find that a bulk of the piles which are executed all across the world, you'll find 26% comprise the large diameter pile and 22% the continuous flight agar pile, which means there is a good scope for replacing at least 30% of the board pile with the CFA pile, which means even if we have a replacement of 26% of board pile, 30% of this will close to be about 6 to 8% at least we can have a CFA pile in India. So that speaks of a good opportunity for CFA piling in India. Now, there are systems in vogue which we adopt for the board pile in which a hydraulic rig is used, a winch method having a tripod, baler and a chisel method is also used for board pile. Now, in order to have a high productivity of the pile, we can have a CFA pile which can replace the board pile in the range of 50 to 150 metric ton, which means the diameter of such pile will be in the range of 300 to 700 mm. So having said this, the available rotary rig can be converted into a CFA piling kit with a minor modification. So what are the advantages of CFA pile? They have a lot of benefits. You don't require a stability fluids. Your housekeeping is greatly improved. The sites are relatively very clean. And the foremost advantage of CFA pile is they have a very fast productivity rate. Then what is the present scenario? They are not at all executed in India. Why? There is apprehension that the cage pushing into wet concrete should be a problem. Concrete supply logistics are still not smooth in India, and there is no code, standard, or guideline for CFA pile in India. That means there is a need for standardizing such piling practice in India. It is with this scenario that DFI of India has come up with a novel initiative to have a demonstrative project for CFA pile and make all attempt to have an inclusive piling technique with CFA pile and make sure that India embraces this piling technology in as much fast as possible time. So how do you save time with CFA pile? There is an absence of temporary liner, there is absence of frequent disposal of mud, there is absence of stability fluid, and yes, there is no washing and trimming repetitive operations. These are all effective in minimizing the CFA piling time to great extent. What can be the favorable scenario? Alluvial soils, yes, CFA pile is mostly applicable. If it is sedimentary deposits with smaller layer of varying layers of clay and silt, yes, it is applicable. You will find almost invariably the CFA pile can be applied wherever you have a agar that can be penetrated. It cannot be penetrated into a weathered rock. It cannot go into the rock. It cannot go beyond a SPT value of, let us say, 40 to 50 numbers. So which means it's not a easy magic solution with a CFA pile, but yes, you require a discretion and understanding of the subsurface condition in order to decide the suitability of the CFA pile. So these are some of the scenario I have presented where you can make out to what subsurface condition the CFA pile will be suitable. I can make use of a dry sand deposits and a collapsible soil where CFA pile should not be used. If there is a thick layer of clay overlying a shrinkage cracks, it may not be applicable. So having used a discretion that yes, CFA pile has its uses, has its demerits, and in certain situation, we see how the equipment can be adapted in Indian condition. In order to have any such piling practice popularized in India, the equipments should be very easily available. The mobility of the equipments, the economy of the equipment should be of a prime concern. Now, what are the actual equipments you can use? You can use the crawler mounted cranes, you can use a hydraulic rig, you can modify them to place the flights. The torque applied will vary from 28 to 120 kilonewton meter for crane mounted rigs and from 90 to 400 kilonewton meter for hydraulic rigs. So both of these can be easily modified to house the continuous flight. Ground force can easily be adjusted up to 4.5 tons for crane mounted and for 27 tons up for the hydraulic rig. In fact, you'll find that there is a great scope for housing the continuous flight with a conventional crawler mounted crane and a hydraulic rigs. So that makes equipment adjustment quite suitable under Indian condition. So these two figures I have put up. On the left, you can see the crawler mounted CFA rig, and the second one on the right, you can see the conventional hydraulic rig that is suitably adjusted to include a continuous flight. So coming to what are the plants, machinery, equipments required as a methodology for conducting the CFA piles. First of all, you require a CFA rig. The CFA rig will have a CFA kit. It will comprise the CFA with the attachment of drilling bits. It should have a sleeve, a rotary head, the cat head, auger guide, sensors to record the technical data. It should have an automatic measuring device which should be housed within the panel of the rig so that a real-time monitoring of all the drilling data will be possible. You can see the various attachments. The auger head is fitted. You can see at the bottom there is a concrete plug. It can be removed. The plug can be removed to allow the concrete to gush in and occupy the pile bore. Here you need some kind of mechanical removal so that you can remove the spoil continuously as your auger is being picked up and it moves upward. There has to be a continuously flow of concrete so that you require a concrete pump so that the concrete flow of about 42 to 79 meter cube per hour should be possible. So that means a concrete pressure of about 108 to 60 bars should be exerted, and that can be applied into the pile bore, and it exerts a good deal of pressure into the pile bore. The delivery pipe is normally a conventional pipe about 125 mm. So the whole setup is so that the continuous pouring of the concrete is taking place as you raise the auger at the top. You require about 35 to 45 metric ton hydraulic cranes so that you can push the rigid cage into the wet concrete. Removal of spoil is very important as a housekeeping, and the place around the piling should be clean and it should be devoid of any such excess mud. So your mobile excavator should always be ready to remove any muck that is being collected by the auger. In case you find that the cage is not willing to go under its own self-weight, it is always wise to deploy a ring vibrator so that a cage can go under its own self-weight into the wet concrete. Once it ceases to go by weight, then you can deploy the ring vibrator into the to be pushed into the wet concrete. Generally, a wet mix design of the concrete should be such that the weight of the cage should be sufficient to allow and the cage should be driven by itself under its own weight. So this demands that the cage has to be rigid, number one. Number two, that the concrete which are being used should have a very high degree of workability. Preferably, the ring vibrator should be brought into picture only under emergencies. We should have a batching plant readily available and installed within the vicinity of the piling operations. Minimum capacity will depend on what is the productivity rate of the piles, what are the number of piles you are executing per day. Generally, a 45 to 60 to 90 cubic meter per hour of batching plant will meet most of our requirements. You need to have a very rigid cage. In no form, the binding wire should be used. Your cage should always be welded to the spacer bars. Preferably, the cover blocks should be as close as possible so that a cage can be guided into the bore in as vertical manner as possible. As I see that this was one of the concerns raised by one of the audience, how a verticality of the cage can be maintained. There are two aspects to be considered. One, the spacer bar has to be as close as possible. Number two, the cage has to be as rigid as possible. Number two, the cover block should be spaced as close as possible so that the roller action of this cage will be facilitated and will be having a vertical movement of the cage into the pile bore. Apart from that, all the arrangement to maintain the verticality of the pile bore shall be ensured by the panel of the rig, so that our pile will be vertical and it will be monitored from the rig panel. You can have a look at the acrylic type of cover blocks. It will ensure a minimum requirement of a cover which varies from 50 mm to 75 mm. These piles can also be instrumented. One such instrumentation we have provided. We have provided embedded data collectors along with some of the thermal integrity profiling sensors. They were connected to the data logger, and we had two piles instrumented during one of our trial exercise at north side of the Delhi. Quality control, quality assurance measures for CFA pile is one of the major concern, major attention that needs to be provided. And there are certain aspects that quality control needs to be attended. First is the mix design has to be very, very appropriate. The steel cage has to be very rigid cage. It should have a sturdiness and strength. The rate of agar advancement and withdrawal is one of the important quality control too. And the actual operator who is operating the rig should be well versed with the rate of advancement and withdrawal. Quality of the grout or the concrete is of prime concern, which means the mix design should be perfect. It should have adequate strength. Workability is to be maintained in a proper way. If you have to perform a cage driving in a wet concrete, your slump should be minimum 200 mm. 200 mm will be difficult to measure by a conventional slump measuring device. In fact, we have a better measure which is called a slump flow value, which is measured by the invert Abraham cone, and it has to vary from 760 to 890 mm, which should ensure that there has to be certain flowable concrete which will allow the cage to be accepted and inserted into the wet concrete column. Sturdiness of the cage, as I have defined, the sturdiness will be defined by having more number of main steel rather than lesser number of main steel of large diameter. The rings have to be very closely spaced, about 150 mm. They have to be welded to the main bar. The spacer disc has to be welded to the main bar, and at the same time, you need cover blocks that should be as nearly spaced as possible. The automatic measuring unit that is housed within the panel of the piling rig. This is a must and a compulsory mandatory provision the piling should have. While we are trying to introduce such piles in India, we are making it mandatory that all the rigs should be housed with the automatic monitoring device that will give you an insight of what is the pile profile, what is the concrete volume, the grout factor, and many other measurable parameters. And it gives you a runtime idea of a real field idea of the progress. You can provide an actual assurance test by having a static pile load test at end of the execution. You can have few piles to be tested. They are called the probe piles. Once the probe piles have established that CFA piling is possible, then you can convert these probe piles into test piles. That is the initial test piles. If something has gone wrong with the probe pile, then you can have a dedicated additional test piles to perform the initial load test. After success of initial load test, then 0.5 to 2% of the working pile, as per tradition, will be earmarked for the routine test. Then you can also perform the high strain dynamic load test, or what we call simply a dynamic load test on the working pile as well as the test piles. Some of the few integrated tests you can perform, it can be low strain dynamic test, or it can be a cross hole integrity test, or it can be even a thermal profiling, as we have done in one of our trials. So this is a typical profile we get of thermal integrity, and it gives you a continuous monitoring right from top of the pile to the bottom of the pile. A brief background on the design approaches for the CFA pile. The traditional approach for the pile design, which is applicable for board pile, we split up the capacity into the end bearing as well as the side shear, to which the weight of the pile can be detected. This is the conventional equation which is applicable also for the CFA pile. But over here, some limitations are shown by use of the IS formula or even the IRC formula. A better approach will be that we go in for FHWA method, which has a very forthright choice of the parameter. There is a clarity, there is a transparency of the choice of the parameter, and the variability in the choice of parameter is not seen in FHWA. So this is what we want to propose in our draft guideline for the CFA, which we are intent to submit to the PISA committee. In FHWA, we have two approaches. One is you find the ultimate capacity and then you divide by the global factor safety. Or the second is based on the serviceability condition, just like our own IS code, in which a limiting total settlement criteria under working load becomes a certain criteria for accessing the safe load. The combination of the two is usually appropriate, and it takes care of the design and the performance. So you will see that the safe compression capacity based on the limiting settlement criteria, normally we get it from the load test. It will be a certain limiting load we have got divided by a certain factor of safety, that is 1.5. This is the traditional method. In FHWA, either you can have a global factor of safety, which will depend from 2 to 2.5, depending on whether it is a softening or a hardening nature of the pile-soil interaction. Or you can have a suitable partial factor of safety applicable for the side shear, which varies from 1.5 to 2, or it can vary from 2.5 to 3 for the end bearing. Same thing is applicable for settlement criteria, where the load test data can be used, and we can have a factor of safety of about 1.5 if it corresponds to a settlement, or if it is 10% of pile diameter, then factor of safety will be 2. This is as per our normal practice of 2911. If you see the cohesive soil, you will find that a cohesive soil can be split up into two parts. One will be the side shear contribution. Side shear is better addressed by a alpha factor, in which alpha factor is seen to vary from 0.55 to 0.45, and the factor for variation is defined as the undrained shear strength divided by the atmospheric pressure, which is taken as 101 kPa. So there is a very, very clear-cut understanding of how the alpha choice should be arrived at. If we see the ultimate capacity in bearing, it will be Q max into the base area. Q max is by tradition, it will be NC into the shear strength of the clay. NC will be around 9 or it can be less than 9. It will depend on a certain factor that is called a rigidity index. In fact, a rigidity index will give you a guideline for what will be the value of NC to be adopted, which will be in a range of 6.55 to 9.0. At the same time, it is very clear what value of shear strength you can apply. It will depend on your SPT 60 value or the cone resistance. Now, if you find that the embedment depth is less than 3D, then you have a choice. You have a reduction factor or a multiplying factor so that you can apply for a reduction in the pile capacity. In fact, FHWA has been recommended in our proposal for carrying out the pile capacities for both the cohesive as well as the non-cohesive soils. If we come to the cohesionless material, we have a very candid definition of a certain factor, beta factor, that takes into account the in situ behavior of such pile. A beta factor over here is very clearly defined. FSI, you'll find, is a function of the vertical stress, the overburden, multiplied by the beta factor. The beta factor has been seen to vary with the SPT and it varies with the depth. So without going in for any form of variation of the overburden pressure, the beta factor has been clearly used to analyze and to find out the capacity in terms of side shear for the cohesionless material. The skin friction for a cohesionless material, we can use a 0.75 factor if we are taking up the uplift value of the CFA pile. If you see the end bearing resistance of the CFA pile, traditionally a method we adopt as per the IS code is also applicable over here. Only thing here, you have a very clear picture that the Q max is a function of a N60 value, and this is limited to 4.3 MPa, just as a guideline to prevent any such unsafe practice in terms of the pile capacity. So over here, Q max, if you express in terms of the CPT resistance, it will be restricted to 0.375 with a limiting value of a unit pressure as 4.3 MPa. So this is not a wholesome discussion I had been putting up in terms of the pile design, but rather a few guidelines which will be available to everyone by a shared presentation. It is a driving point to note that some of the limitations of the IS code has been overcome in our proposal for the CFA design by using a FHWA guideline. In order to popularize the concept of CFA pile, DFI of India has went on to carry on CFA trials at Hisar. So Hisar, you will find it is located about 210 kilometers northwest of Delhi, where we had access to the site where the ongoing project was going on, and we had been earmarked for a trial patch for carrying out the trial piles. We find that the soil condition was mostly a silty soil with a ground water table available close to about 1 to 3 meters below the ground. And we were in position to do the CFA pile up to a depth of 11 meters below the ground, where you find that the N values were found to vary from 23 to as high as 35 meter at about 11 meter below the ground. We had planned for 8 piles. Out of the 8 piles, 2 piles were essentially probe piles, and they were followed by 6 piles which were to be tested for vertical, pull-out, and the lateral test. We had also performed the low strain dynamic test for each of the pile, and all these piles indicated a perfect integrity, indicating that the quality assured or the quality related to the CFA piles was in perfect control, and we had a very plumb vertical walls of the CFA pile. The cage was a very sturdy cage. We had used about 20 diameter pile, diameter bars, 10 numbers, 10 spirals were used. They were spaced of 150 center to center. Then the spacers were actually spaced at 1.5 meter center to center. Instead of going in for rings, we had used the flats for spacers, and throughout the helix, the spacers were welded to the main bar to apply a rigidity to the cage. The piles were also instrumented. We had 3 levels of embedded strain gauges, which gave us data for the performance of the pile in terms of the load spread or the load distribution along the length. So that gave us an ample idea of what is the contribution in side shear and what is the contribution taking up in the end bearing. So these were the sequences of the pile we had executed at the site. On 27th of May 2019, we started with the first pile, that is the probe pile. On the second day, we took up the second probe pile. The third day, we completed 3 piles, P6, P1, P2. And on the last day, that is on 30th of May, we completed the remaining 3 piles. So out of these 3 piles, we had performed 2 load tests, that is a vertical load test on 2 piles, pull-out load test on the remaining 2 piles, and 2 load tests, lateral load tests on the 2 piles. So they were carried out sequentially 3 months after the execution of the CFA pile at the site. So some of the snapshots are being shown to you. This is a panoramic view. You can see the piling operations in progress. The cage is being ready, and you can see the crane is, we have a tire mounted crane so that it offers mobility and thickness of the movement. All the actual resources should be available right before the construction of the execution of the CFA pile commences. You can see the concrete pump is also ready with all the tubes that connects to the top of the CFA unit. The cage being fabricated, rigidity of the cage is one of the prime element. Over here, the concrete tube is being extended to the top. Note, we have a cleaning operation be taking place by JCB. A concrete slump test taking place. In fact, it is a flow test. We had ensured that 750 to 800 flow value was ensured for the concrete. It was a summer season where the temperature of operations was 47 to 48 degrees Celsius. Despite that, we had been able to manage well with the concrete. Over here, as soon as the concreting is done, you'll be removing the rig, and then you'll be lowering the cage with which is suspended through the crane. Gentle guidance will be required manually, and then the cage will start moving down automatically. In case few portions, if it is run go, you can push the cage through a gentle nudge of your JCB unit. After a cage is driven, the wet concrete, you can see that the cage has been fully inserted. In fact, during our trials, we had not used any form of vibrators, which we feel that anytime the vibrator, if it is deployed during emergency, is always going to assist you well. We had performed the load test on the CFA piles. P2 and P3 were subjected to a vertical load of 180 ton, close to that. And we found that the maximum settlement was 12 under the test load. Then we had conducted the lateral load test. The lateral displacement was maximum 2.06 and under 12 metric ton load. That showed an ample value of lateral resistance. Over here, we had performed the pull-out load test also, and we could see that it had performed fairly well. What was the accomplishment with the trials? We had been able to successfully demonstrate that the pile can take up with good quality various vertical test loads which it was designed for. In fact, all the tests revealed that ultimate capacities were 15 to 20% higher than the estimated capacity. While this is very positive outcome, an upward revision of the design input parameters can also be recommended for based on the pile load test. We have come up with 4 important publications that will serve as a guideline for the Indian masses, particularly the geotechnical engineers, the aspiring designers who need to design the CFA piles. The guidelines that are ready are a design and construction guideline for CFA pile. This is nothing but a form of a curtain raiser for a draft Indian 2911 code. Then there is another document that is a pile design and construction. It gives you an idea of the various design that went into the construction of the trial piles we executed at the site. Then the execution report is brought out in the document number 3. And document number 4 is a compilation of all the load tests which we had performed on our trial piles. These documents can be available if any written query is provided to the DFI of India. Now, with this attempt to demonstrate the piles, we decide now what is the way ahead for the CFA pile. In fact, the efforts are on in bringing the CFA pile design and construction as a standard Indian code in 2911 series. The CFA committee, of which we have a group of experts, they are putting continuous effort to facilitate implementation of the CFA pile technology in India for many future projects in India. There is opportunity for CFA piling execution at the site in Rajasthan, and we request the sponsors, we request the client, we request the equipment agencies to come up forward and supply us a CFA kit along with the rig for a possible win-win situation where we can execute the working piles as well as test piles for the Rajasthan location. You can see the support is desired for arranging the CFA kit that could fit into the hydraulic rig that are normally operational in India. With above arrangement, it is possible a convenient execution of CFA pile without a heavy investment. These are the teams that were involved in the execution of the trial demonstration project of CFA piles in the North India. It has a lot of contribution, a global contribution, and a widespread support we had received from India as well as across the globe. Big thanks to all those who were involved in this CFA project. With this, I conclude my presentation with a big thanks to IGS Delhi chapter and DFI of India for the opportunity to share my experience. My special appreciation to the learned audience for the kind attention they have provided. And I leave now for a question-answer session.
Thank you very much, Dr. Basarkar, for your wonderful presentation and at least created glimpse about what's going on in India about CFA piles. So now we can, take up the question answer round. So yes, so I just see that we already got few queries from audience. They're available in the chat box. Oh my God, so many. Yes, send your question. Okay. It's written that what are the advantages and disadvantages of a CFA piles in comparison with the conventional board casting C to RCC pile from the construction point of view, as well as from the pile step integrity and the mobilized load carry capacity point of view. Please comments.
You want to compare the conventional pile with the CFA pile as far as the progress is concerned. You will find that for the same diameter pile, the same length pile, if we have a contemporary board pile, the board pile is going to take about 1 hour for execution. That will include the boring, putting on the cage, and having the borehole cleaning, and followed by the concreting. So the contemporary board pile will take about 1 hour, whereas the same CFA pile, if we use of the same diameter, same length, that can be very conveniently be completed within a half an hour. One thing that is a very guaranteed feature of the CFA pile, if you have all the logistics in order at the site, which means your rig is ready, your concrete pump is ready, your cage is ready with the crane, and the JBC is actually available at the site, you'll be able to actually perform the CFA pile with a finesse, with a full quality assured. So quality is a big guarantee for the CFA pile.
So next question by Mr. Ranjan Peter is asking, can you adopt CFA piling for mass housing project of port storage wherever the geological condition due to its speed and cost?
Can you repeat the query?
He is asking, can you adopt CFA piling for mass housing project of port storage building?
In the offshore area, you're telling? Sound is somehow not audible clearly.
He's not specifying the exact the geological condition, but he's saying that where the speed of the construction and cost is the matter, can you adopt that CFA file where you have to construct very fast and it's a basically mass housing project?
In fact, I'll put up through the chat box. The questions are still eluding me. I'll read out the question which is raised by Mr. Rajan Peter. We should also get CFA piles included in the tenders. This question put up by Mr. Rajan Peter, I would say yes, CFA pile should also be put up in the tenders, because it is up to the client to take up the cause of CFA pile. The tender should have a very, very clear provision that there has to be a certain number of probe piles. The probe piles will actually demonstrate that with the kind of logistics arrangement at the site, you'll be able to demonstrate that CFA pile can be executed. So that is the essence of the probe pile. Once the probe pile has been put up, we'll have to conduct the load test, initial load test. So to establish what is the capacity of this CFA pile. So once we say that it has to be included in the tender, we have to ensure there has to be a provision for the probe pile, there has to be a provision for the test pile, and there has to be a QA QC provision for the working pile, which should include the non-destructive testings, and it should include also some of the working piles load test, which will be static load test or the dynamic load test. So I think with that, we can find definitely a reality of having the CFA piles to be included in the tender, and see that India's dream of having CFA piles are realized. I take the second question, which is visible to me in the chat box, which is from Professor Dasaka Murthy. How would you ensure whether the cut soil is fully removed from the ground before concreting? In fact, CFA pile is a continuous process, which means a part of the agar is always filled up with the soil, and only about half a meter to 1 meter of the agar will be inserted in the concreted pile, which means as the concrete is taking place, you are also trying to raise the agar carefully. So it means only half a meter of the agar with soil will be into the the pile bore, and some portion of the pile will always be above the cutoff, which will mean that you should be able to remove the contaminated concrete as conveniently as possible. So that means it is always possible to remove the soil from the agar as you raise up periodically. The removal of the soil can be either through the mechanized drum, or it can be through mechanical means by employing the laborers at the spot. I take the next question, if you, Dr. Manna, if you permit me, from Jigisha Vashi. She is asking, what about the cost of CFA pile in comparison to the board pile? In fact, the answer to this is high productivity rate. It will mean that cost of pile of CFA or the board pile, if you see 1-to-1, most of the measurement is through the material quantity. The cost will be same on paper, which means the cost of the same diameter, same length CFA pile and the board pile will be same. But the advantage with the CFA pile will be with the productivity, which means CFA pile can be executed in half the time in what you are going to execute the board pile, which means if the time is reduced by 50%, your resources utilization time will be reduced by 50%. That means the resource allocation, the cost towards the resources is reduced by 50%. So that gives you an advantage and a cost saving edge. I take the next question from Pooja Desai. Why can't we use CFA pile in sandy soil? I will say yes, we can use CFA pile in sandy soil. Why not? We can use it, but provided N value should not be so high. The next question is, can the same concept of not using CFA pile in sandy soil be applied to helical piles also? It is here I differ. I have already stated that CFA pile can be executed in the sandy soil. In fact, it offers a better advantage in sandy soil by maintaining a verticality of the hole. Since you don't require any stability fluid, your own agar filled with the soil itself acts as a it stabilizes the vertical hole. Once you start replacing the soil with the concrete, you'll find that at all portions, you'll find that the bore is always supported. During the downward movement phase, the bore is supported by a downward movement of the agar filled with soil. During upward motion of the agar, it is supported partially by the concrete and partially by the soil filled with the agar CFA. So this is the advantage you have about the CFA pipe. Pranav asked me one question. Why should be the minimum quantity of pile so that this method is feasible? I'll say there has to be 1,000 number of piles, because our intention is to have a small diameter pile up to 600 mm, which means this pile will be able to take load from about 70 ton to as about 120 ton. A small diameter pile, a small capacity pile will imply more number of piles will be required. So about 1,000 piles should be a minimum economic criteria for the number of piles we should have for economic deployment of CFA piles. Thank you. I could see these questions in the chat box. Thank you very much. Any questions I can still entertain?
There are two more questions which can't be addressed because of the time constraint. I think the DFI can put up the question separately to Dr. Basarkar and he will reply, and I think we can send it back to the audience. And therefore, we can, we just thanks to Dr. Basarkar for this wonderful presentation and to get the complete picture about the development of the CFA pile in India. Thank you very much, sir.
Thank you. Thank you very much.
So now in the closing session, I would just like to know that what are the sequence of the works went out. And basically, we started with the workshop overview about the IGS Delhi chapter activities by Ms. R.P. Varghava, Chairperson, Chairman of IGS Delhi chapter. Then we had a complete overview of DFI India activities by Mr. G. Venkataprasan. And we have the three wonderful presentations. First one on difficulties of alluvial soil and possible way forward by Professor J.T. Shahu from IIT Delhi. He presented about the board's casting situ pile of 1.2 meter diameter constructed at Gautam Nagar, and he talked about the instrumented pile and different type of static and the high strength dynamic test. He also discussed about the pile dynamic analyzer, PDA, and cathode analysis. He also discussed that cathode pile integrity testing and the cross-hole seismic logging, sonic logging test. And he also presented the different type of the instrumentation used for the testing and what are the different interpretation out of this the instrumented result. And finally, he throw some question to the audience that is very difficult when there is this kind of alluvial soil, and what kind of the challenges we need to face when we are constructing the pile in alluvial soil. So then there was the second presentation done by Mr. Andres Keller UK. We talk about the world case studies on CFA piles from typical project and on extreme application. And he talked about the various process of the and also the applicable soil for CFA piles, discuss pros and cons, equipment use, different pile loading testing, and bidirectional testing system, automated monitoring equipment, and also he correlated that the speed of the installation with the soil profile. He talked about few project summary and in Avalon Hotel, 20-story luxury hotel, Metri in Miami, and also some project in Australia. So that was a very wonderful presentation by Mr. Andres. And we had a third presentation on CFA piles design approach, suitability and application in India by Dr. Sunil Basarkar from Afcons, India. He discussed about some equipment availability and India and construction aspect in details, quality control for the CFA pile, and he also showed a very beautiful automatic metering unit. And he also discussed about the different type of the test normally done for these CFA piles, starting from static load pile, high strength dynamic load test, low strength dynamic load test, PIT, and the thermal integrity test. We discussed in detail about the design approach of the CFA pile, what we can include, take out from the our IS 2911, and also FHWA design approach. And also finally he concluded with some trial piles with some instrumentation, and finally a wonderful accomplishment of the trial with some guidelines. And also there are 4 published documents which is available where we can get more details about the CFA piles. So thank you all the audience. I hope that we learned something which is the new the piling technology, and hopefully we learn many things. And with this, I thank you all of your attention, and see you in the coming webinar. Thank you so much.